Okay, hello and welcome to another section in further mathematics. In this section, we'll be looking at the topic, the minimum and the maximum point in a differential equation. Now, in our previous class, we did so much about differential equation, but before further with this, I would like us to take a big preview of what we did in our last lesson. Okay, welcome back. Now, we stated something when we're treating minimum and maximum value. I gave you some solutions that we actually did in calculating the y, the x of a constant. I told us that when we have a constant, the differential coefficient of that constant is usually equals 0. Now, we did justice to numbers that also have the x factor on them, and we discovered how to do some calculations when it comes to differential equation. But remember, whenever we want to perform calculations in differentiation, I told us that we must endeavor to write this constant. That's the nxn minus 1 factor, because it's usually required. Now, let's go into calculation of minimum and maximum points in a differential equation. Now, let's calculate this. If y is equals x raised to power 4 over 4 plus, let's just make it 4x raised to power 3 over 3 minus 2x plus, minus 16. Now, if you're being given this to determine the maximum and the minimum point of this, okay, just determine the point of inflection. So what you have to do now, you have to differentiate using this factor nx raised to power n minus 1. So we then have, if you differentiate this, x raised to power 4, where our 4 is n, you now have 4x 4 minus 1 over 4 plus this other one becomes 4 times 3. We have 4 times 3, x raised to power 3 minus 1 over 3 minus this is 2x, so we have 2. So 4 goes with 4, and this 3 takes off this. We now have x raised to power 3 plus 4x2 minus 2. So this becomes the equation that we are considering at this point. So we have dy dx to be equals this. But before we move further, I'd like us to understand the concept that we usually apply when it comes to the calculation of minimum and maximum value. And you bear with me that after a series of analysis, you always notice that dy dx is equals to 0. That happens to be the turning point, or you call it the point of inflection at this point. So I would like us to state clearly that when you want to determine the maximum point, at maximum point, you state that the square y over the x square is equal to a negative value. Why the square y over the x square is equal to a positive value when you're calculating the minimum point. Then this is called the point of inflation. So when you're calculating the turning point, we are interested in all this. But at the point where this is equal to 0 is called our turning point. So with this, we now go into solving an equation to determine both the minimum point, the maximum point, and the point of inflation. Now we have our question number 1. We're going to do this together. So we have x raised to power 4 divided by 2 plus 5x3 divided by 3 minus 2x squared minus 3x plus 1. Now let's apply our normal rule of differentiation. You know the rule states nx raised to power n minus 1. That's the rule of differentiation. Now let's go. Our n value here is 4. So we bring it back because it's the value of n. You bring it to the back. We have 4 we have our x, then you have n minus 1, so 4 minus 1 over 2 plus 5 times 3 x raised to power 3 minus 1 over 3 minus 4 x minus 3. So we have, remember what we are calculating now is our dy dx. So this is equal to 4x 3 over 2 plus 5x2, because 3 goes with 3, so 5x2 minus 4x. So and at our turning point we stated that dy dx is equal to 0, and this goes here is 2, so we now have 2x3 plus 5x2 minus 4x minus 3. So at this point dy dx is equal to 0, so we have to solve this. This is a polynomial equation, and we did polynomial equation in our previous lesson. I showed you how to factorize it. So on solving this, the factors are, so our dy dx at this point we have 2x3 plus 5x2 minus 4x minus 3 being equal 0. So the value of x become x minus 1, which is a factor of this, applying the polynomial rule, which is x, we have here minus, so it becomes plus 3, and the last point of it is 2x plus 2x which is 3 plus 1 being equals 0. Now after equating these points to 0, now let's pick our values of x. Our values of x are x is equals to 1, or x is equals minus 3, or we now have 2x plus 1, so equals 0. So at this point our x is equals minus 1 all over 2. Now these are the three values for our x. Now I want us to test if it's minimum or at maximum, but remember that dy dx is equals 2x3 plus 5x squared minus 4x minus 3. And at the turning point, if you want to remember the rule of a maximum and minimum point, so we have to get the second derivative, and our second derivatives can be calculated using the above stated equation. So we now have the square y over the x square, which is equals, okay, let's do this together. Now our n value is 3. Look at the 3 here. We now have 2 times 3 is 6x square, plus 5 times 2 is 10x, plus 10x from here minus 4, so minus 4. So we now have to substitute the respective values of x at this point. If we have a negative sign, then is a maximum point. If we have a positive side, it is the minimum point. And if we have 0, then that is point of inflection. Now let's do a test. We have our values 1, minus 3, and minus 2 over 3. Let's start with 1. At the point where x is 1, let's substitute it. We have x1 square plus 10 times 1 minus 4. So 6 times 1 is 6 plus 10, 16 minus 4, which is equals 12. So at this point is 12, so we have a positive number 12. Now I want us to do, this is for 1. Now let's substitute minus 3 into our equation. We now have 6, then minus 3 raised to power 2. We also have plus 10, the value of x, where our x, remember we are using x as minus 3 at this point. So we put, instead of x, we replace it with minus 3, then minus 4. So minus 3 raised to power 2 is 9. So we have 6 times 9 at this point. We have 6 times 9 plus, okay, it's now minus because we have 10 times minus 3. So we now have minus 30. Then we now also have minus 4. So with this, we now have, if you have the value of 6 times 9 minus 30 minus 34. Then the last one we have minus 1 over 2. If you substitute minus 1 over 2 at this point, you have 6 in bracket minus 1 over 2 squared plus 10 times 1 over 2. 10 times 1 over 2 is 5 minus 4. So minus 1 over 2 squared is 1 over 4. So we have 6 over 4 plus 5 minus 4. So we also have 6 over 4 is 3 over 2 plus 5 minus 4. So let's perform the arithmetic using fraction. We have 3 plus what we have here is 2 times 1, 2 times 5 is 10 minus 2 times 4 is 8. So 8 minus 10 is 10 minus 8 is 2. 2 plus this is 5, which is equal to 5 over 2. Now you could discover that from our analysis and from what we have here, it's possible for us to know that our 6 times 9, okay, 9 times 6, which is 54. 54 minus 30 is 24, minus 4 is 20. Now you can see that from this, our curve, what we have is plus 20. So our curve has just minimum values points in time. So I think we'll have to solve another question in this regard. But for now, I would like to tell you a very big thank you for joining us in this lesson. In order for you to refresh your memory on what we've just discussed, please always take the test that appears on the screen after each lesson. You also do well to use the lesson notes on the platform for a better information on the topic we've discussed. Thank you.